Hello and welcome back to the course on our programming. Today we're going to finally get our hands dirty in the basketball dataset. And also we're going to learn about matrix operations while we're at it. Alright, so let's get started right away. Let's see what kind of tables are at our disposal. So we can see them over here. Let's type some of them out. So let's start with the games table, for instance. Matrix. This is a matrix. So here we've got the players, and we've got the years, and as we now know, this is a named matrix, so basically it's got row names and column names. So if we check row names of games, we will see that that's the names, and same for column names, we will get the similar result. So let's check games. We see that it does have games. So basically it's a matrix, right? And now we know how to access it as well. So if we want to, for instance, check how many games LeBron James played in 2012, we would say games, and then instead of trying to figure out what row LeBron James is on, third row, and then what 1, 2, 3, the number of the column, here we can just simply say LeBron James and then comma, and in 2013 or 2012, whichever year, let's say we want 2012, we check that, we get our answer, 76 games. So here you can see that that is correct. LeBron James played 76 games in 2012. Okay, great. So, but now matrix operations. What can we do with matrices? Well, we know that with vectors, we can do the same operations as we would do with just variables, right? So we can add vectors, subtract, multiply. We'll explore all of that previously in the course. But now, can we do the same things with matrices? Well, yes, of course we can. So let's take another matrix that we have. Let's say field goals, right? Field goals. So this is how many field goals each of the players scored in each of the years, right? So what we can do here is, let's say we want to find out how many field goals every single one of these players scored per game. One way to do it would be to go through every player, through every year, and divide the number of goals by the number of years, like in a loop, or it would even be a double loop, right? You would have to loop by the players and by the years, but that's overly complicated. So mathematicians and statisticians thought it was overly complicated, and they decided that in R, we're going to just divide one matrix by the other, just like we can do with vectors, right? So let's do that. Let's say field goals divided by games. Let's check that out. Now this is way too big of a matrix, so let's run it again. Let's make some space. And there we go. So now you can see how many field goals per game each player scored. If I round this, and I don't give any parameters, if I just do that, or maybe let's give it one number after the decimal, then here you can see how many field goals each player actually scored per game, and it's presented nicer than that. And let's say you want to find out Chris Paul in 2010. Here you go. On average, he scored 5.4 goals per game. And that is what this table is about. That is how a matrix is divided by another matrix in R. It's just simply element by element. So as you can imagine, they have to be of the same size for you to be able to perform this operation. All right, let's have a look at another one. What other tables do we have? Let's bring this back, and here we've got, let's say, minutes played, right? Let's find out how many minutes per game did each player play. So let's do that. Minutes played divided by games. And once again, not enough space. And let's round that. Let's round that to the nearest one decimal point. So, or actually no decimal points for minutes played. So here we can see how many minutes on average per every game each player played in every single one of these seasons. So you can quickly tell, like Derrick Rose, 29 minutes per game over here, then 37, 35, then he was injured, then 31, then 30. And looking at per game stats is actually quite handy, because if you just look at minutes played, what you'll find is that here Derrick Rose only played 311, and you can't compare to the other players, or you can't even compare to the other years, because it's a very low number, or even zero here. But if you divide by games, or what we already have here, it's much more comparable. So you can now compare between different players and between different years, because 31, here you can see that even though he played only a few games, he actually played more minutes per game than in 2014. Okay, so that's how you divide matrices. It's the same thing, you can add matrices, you can subtract them, you can multiply them. In our case, it's just that the type of data set we have, we're mostly going to be dividing one matrix by the other. And but nevertheless, you can still do all those other operations with matrices. And so that brings us to the end of today's tutorial. In the next tutorial, we'll find out how to actually visualize these results that we're getting. It'll be a fun tutorial. We'll start building charts and graphs. And for now, what I would like to do is to invite you to explore these other matrices that you have here and perhaps perform some other operations, like try to calculate the field goal attempts per game, or another good one would be try to calculate the field goals per field goal attempts, and that will give you the accuracy of each player, so you will know how many of the shots that they actually make end up in the basket. Okay, that brings us to the end. And on that note, I will see you on the next tutorial. Until then, happy coding.